Hello everybody, welcome into another lesson. So today we are going to talk about the binomial theorem part 2. And I know in the last lesson when we did part 1 we had that long binomial theorem formula where we basically for every term did the combination of n things r at a time, where we had to do that for every single term. And in theory, that's what they would have you do. But we're not going to do that. What I'm going to show you today is a much easier way. It is based off the binomial theorem. It's found in that, but I'm going to give you a short synopsis basically of what you need to do. That's going to make your life so much easier. So what you're going to do when expanding a binomial to a power, you're going to take, of course, your very first term, raise that to the nth power. So take that x, raise it to the nth power. Let's do the second term now. So if we want to get the second term, what you need to do is go ahead here, and you're going to take that n, that power on the x, take that n, bring it down in front, multiply it by your coefficient on the x. So you would multiply it by that coefficient. And then you're also go back, once you got the foundation set up, go back to your first term. You need to divide by the current number of term you're on. In this case, that's the first term. Let's just do that. And then you're going to take your x power, lower it 1 degree. So that would be x to the n minus 1. And then you'll raise your y, your second term, power 1 degree. So that would be y to the first. And then let's build the second term. So to build the second term, I'm going to yet again take that power on the x, bring it down in front of my coefficient here. So this would turn into n minus 1 times n. And now, let's pretend this is simplified. This would just end up, of course, anything divided by 1's itself. What you're going to do is you're going to go back to your previous term. The previous term number was 2, right? You're going to divide that coefficient by 2. Go ahead, lower your x power yet another degree, so that'd be x to the n minus 2. And then raise your y power another degree times y to the second, until eventually you'll just end up with that last term of the binomial raised to the nth power. That's eventually where you end up. So what you want to do, always take your first term to the highest power. And then for the intermediate terms, like to get the second term, I'm going to take that n, bring it down in front of my coefficient on the x, divide by the current number of term I'm on, which is 1. And then I can do the plus n over 1 times, I'll take my x, lower that 1 power, and then raise my second term y 1 power. And then to get the second term, I'll take that n minus 1, bring that down in front here. So I'll have n minus 1 times n. But if I go back to my second term, that is the second term, so I would divide that n minus 1 times n divided by 2. I'll lower my x power yet another degree, raise my y power yet another degree, until eventually I should end up with just my second term of the binomial raised to the nth power. Now I know in the abstract that sounds a little tough, but we are going to do some examples here. So why don't I just start with x plus y raised to the third power. Let's take x plus y to the third power. So x to the third, of course, would be our very first term. Now, how am I going to go about getting the next term? I'm going to bring that 3 down in front of my x, the coefficient on the x, which is 1, so I'll just have 3 times 1, divide by the current term number I'm on, which is 1, so that would just give me 3, and then I will lower my x power 1 degree, which would put me at x squared, times my y power to the first, which would just be y. Now let's go ahead and build the second term. I need to bring that 2 down in front of the 3 and multiply that. Well, 2 times 3 is 6, right? If I divide by the current number of term I'm on, well, 6 divided by 2 is also 3. So I'll end up having 3 times my x lowered yet 1 more power, which would just be x to the first. I'll raise my y 1 more power, so y to the second. Now we should have 4 terms because this is to the third power. Remember, the number of terms you have is always 1 more than the power the binomial is raised to. So we're going to have a 4th term, which would put us on the last term. So if I want to get the coefficient for the 4th term, I'll take that 1 on the x, multiply it by my coefficient of 3. Well, 1 divided by 3 is 3. Sorry, 1 times 3 is 3. Divided by the current number of term I'm on, which is the 3rd term. 3 divided by 3 is just 1. If I lower my x power yet another degree, that's x to the 0, which is also 1. So we'll have 1 times this y raised 1 more power, which would just be y to the 3rd. So now we have found all 4 terms of this binomial expansion. This ends up simply as x to the 3rd plus 3x squared plus y plus 3xy squared plus y to the 3rd. And I got some more. I'm just starting with basic binomials. We'll get into a few more complex ones as the lesson progresses. Let's say I give you something like x plus 2 raised to the 4th power. So this time we're going to take a binomial to the 4th power, which means we should have 5 terms, since there's always 1 more term than the power you have. So we're going to take x plus 2 and raise it to the 4th power. Okay, we'll always start with your first term raised to the highest power, so that'll be x to the 4th, plus we want to get the next term, so bring that power of 4 down in front and multiply it by your coefficient of 1 on the x. 4 times 1 is 4. Divide that by the current term number you're on, which is 1. 4 divided by 1 is 4. So this would be 4 times my x power lowered 1 degree, so that would be x to the 3rd. Now I got to take this term of 2 and raise it 1 more power, or just simply times 2 to the 1st. Okay, now I want to get my next term. Well, I need to take that 3, bring that down in front of my coefficient on the x and multiply it, so 3 times 4 is 12. If I take 12 and divide by the current term number I'm on, which is 2, well, 12 divided by 2 is 6. I will lower my x power yet another degree. I'll have, so 6x squared times my 2 raised 1 more degree, so this would be times 2 to the 4th. Let's go ahead and get the next term. So if I want to get the next term, I'll take that 2, bring it down in front of my 6 and multiply it. Well, 2 times 6 is 12. But if I divide by the current term number I'm on, which is 3, that gives me 12 divided by 3, which is 4. So I'll take 4 times my x power lowered yet another degree. That would just be x to the 1st times that 2 raised to the 3rd power. And then we should have 1 more term. So if I want to get my last term, I'll bring that 1 that's on the x down in front of the 4 and multiply it. Well, 1 times 4 is 4, divided by the current term number I'm on, which is 4. 4 divided by 4 is 1, times x to the 0, since we lower the x 1 degree. That's simply 1, so you would just have 1 times 2 to the 4th, or 2 to the 4th. Okay, so we have 5 terms now that we can simplify. So this is going to end up then being x to the 4th, of course, for the first term, plus, we can now take that 2 times the coefficient of 4, that would give me 8x to the 3rd, plus, okay, so 6x squared times 2 squared, this would turn into 6x squared times 4, plus 4x times 2 to the 3rd, that would just turn into 4x times 8, plus 2 to the 4th, which is 16. Which, if we simplify one more time, the final result should be x to the 4th plus 8x to the 3rd, and then 6x squared times 4, so this should be plus 24x squared, plus my next term, 4x times 8, that should just be 32x, then plus 16. That would end up being all 5 terms. So we'll have here x to the 4th plus 8x to the 3rd plus 24x squared plus 32x plus 16. Let's do one more somewhat easier one. Okay. I like this one. Let's do x minus 2 raised to the 5th power. So yes, we're actually going to expand something to the 5th power, which means we should have 6 terms since the power is 5. So the quantity of x minus 2 raised to the 5th power. So first, again, take your very first term, that x, raise it to the 5th power, plus, alright, let's form the second term. So bring that 5 and bring it down, multiply it by your coefficient of 1 on the x. Well, 5 times 1 is 5, right? If you take that 5, divide it by the current term you're on, which is 1, you still get 5. So that'd be 5 times my x power lowered 1 degree, so that would be x to the 4th. But then I have to consider this negative 2. So since you have a minus, remember that's negative 2. You'll take that times that negative 2 raised 1 degree, which would just be negative 2 to the 1st. Now let's form the third term. So what I have to do now is take that 4, bring it down in front, multiply it by the 5. 4 times 5 is 20. Well, divide by the current term number you're on. 20 divided by 2 is 10. So this would be plus 10 times my x lowered yet another degree. So that would actually end up being x to the 3rd. Then times my negative 2 raised 1 more degree, which would be negative 2 to the 2nd power. Let's form the next term. Alright, so I need to bring this 3 on the x down in front, multiply it by the 10. Well, 3 times 10 is 30. Divide by the current term number I'm on, which is 3. 30 divided by 3 is 10. So that'd be plus 10. Times my x lowered yet another power, so that'd be x to the 2nd, and then raise my negative 2 another power, so times negative 2 raised to the 3rd, plus, let's get the 4th term. Okay, so I need to bring this 2 that's on the x down in front, multiply it by my coefficient of 10. 2 times 10 is 20, divided by the current term number I'm on, which is 4. 20 divided by 4 is 5. So this would be plus 5 times my x lowered yet another degree. That would just be x to the 1st times that negative 2 raised to the 4th power. And then, so we've gotten 5 terms. We should have one more term of 6. Well, what I need to do now, take that 1 that's the power of x, bring that down in front of my coefficient of 5, multiply by that 5. 1 times 5 is 5. Divide by the current term number you're on. 5 divided by 5 is 1 times x to the 0, which is also 1. So you would just have 1 times negative 2 raised to the 5th power. So there's all 6 terms. Let's go through and simplify this. So you'll start with x to the 5th. Now you would just have negative 2 times 5 on your second term, so this would be minus 10x to the 4th, plus, let's take 10x to the 3rd, times what is negative 2 to the 2nd? That's actually positive 4, plus you'll have that 10x squared times what is negative 2 to the 3rd? Well, that's negative 8, plus 5x times negative 2 to the 4th. Well, that's exactly what it would be. So 5x times negative 2 to the 4th, that gives you times 16, plus your final term of negative 2 to the 5th, that's going to be negative 32. So let's simplify one more time. You should end up with x to the 5th minus 10x to the 4th plus 40x to the 3rd minus 80x squared plus 80x minus 32. So there is your expansion of x minus 2 raised to the 5th power. Remember, whenever you're dealing with a minus, that's really the same thing as x plus negative 2. You have to consider this a negative number as the whole term. So this is all 6 terms of this expansion. Okay, now let's pick some different coefficients here. Let's do just a couple that have different coefficients besides 1. So let's say I take 4x. I'm going to take 4x plus 3y and raise that to the 4th power. So I'll take 4x plus 3y, raise that to the 4th power. Well, again, now you have to consider each of these terms as a whole, okay? So what I'm going to do first, take that whole 4x term, raise that 4x to the 4th power. Now what I need to do is bring that coefficient, to get the next term, bring that power 4 down in front, multiply it by the coefficient that's on the 4x. Well, that refers to the coefficient outside of the parentheses, not inside. That would be 4 times 1, which is 4, divided by the current term number I'm on, which is 1. So 4 divided by 1 is 4. So this would be 4 times that whole 4x, lowered 1 power, which would be to the 3rd power, times that 3y, the whole 3y term, raised 1 power, or in this case, just simply 3y. Let's go ahead and get the next term. So to get the 3rd term here, so I'm going to take that 3, bring it down in front of my coefficient on the 4x, which is outside the parentheses. 3 times 4 is 12. 12 divided by term number 2 is 6. So this would be 6 times my whole 4x term lowered 1 power. So that'd be 4x to the 2nd. Times my 3y raised another degree, so that would end up being 3y squared. Plus, let's get the next term. So I'll take that 2, bring that down in front of my coefficient of 6. So that would give me 2 times 6 is 12, divided by term number 3, that's 4. So that'd be 4 times my 4x, lowered 1 degree. Well, 1 more degree lower would just be to the 1st power, times that 3y raised another power, so that'd be 3y raised to the 3rd. And then I should have 1 more term. So to get the final term, I'll take that 1 that's on the 4x, that power of 1, bring it down in front of my coefficient of 4, multiply it by 4, and I would get 4, divide by the current term number I'm on, which is also 4. Well, 4 divided by 4 is 1. This would be 1 times 4x raised to the 0. Well, anything to the 0 is 1. So you're just going to have 1 times 3y raised to the 4th. So this would be plus that 3y raised to the 4th power. Now we have all 5 terms. Let's simplify this. Alright, so 4x to the 4th, that simplifies into 256x to the 4th, plus the next term. This is going to be 4 times, well, 4 to the 3rd is 64, so this would be times 64x to the 3rd times 3y, plus 6 times, now 4x squared, that's 16x squared, times 3y squared, that would end up being 9y squared, plus, alright, so 4 times 4x, we can just say that's 16x, times 3y to the 3rd, that'd be times 27y to the 3rd, plus the final term, 3y, that quantity to the 4th, would end up giving me 81y to the 4th. So let's go ahead and simplify one more time. You'll end up having 256x to the 4th, plus, let's go ahead and multiply all these coefficients on the variables. Well, I know 4 times 64 is 256, but what's that times 3? Let's see. That would give me 768. So this would simplify into 768 x to the 3rd y, plus, alright, let's multiply the next coefficients. So 6 times 16, 96 times 9, that'd be plus 864 x squared y squared, plus, let's do this one here, the 16x times 27y to the 3rd. Well, 16 times 27, that's 432. So you get 432x y to the 3rd, plus your final term of 81y to the 4th. So there is this binomial expanded to the 4th power. You end up with 256x to the 4th plus 768x to the 3rd y, plus 864x squared y squared, plus 432x y to the 3rd, plus 81y to the 4th. Alright, one more slightly harder one, then we're going to change it a bit. Now, alright, so we have x to the 3rd minus y raised to the 6th power. So we have x to the 3rd minus y, that quantity raised to the 6th power. Okay, so that means we're going to have 7 terms, so it's going to get a little hairy. But first thing we do, we take that whole x to the 3rd term, we're going to take that entire x to the 3rd term, we're going to raise that to the 6th power. Now to get the next term, we're going to bring that 6 down in front of that coefficient outside the parentheses on the x to the 3rd. Well, 6 times 1 is 6, divided by the current term number you're on. Well, that's the first term, so that would just be 6 times, I will end up taking that x to the 3rd power to one lower power, which would be to the 5th power, Then I'll take my negative y. Remember, that's a negative y. I'll raise that up 1 power, which would just be to the first power. Now let's get the next term. So I'm going to take that, bring that 5 power down in front here, multiply it by that coefficient of 6. Okay, well, 5 times 6 is 30 divided by the current term number I'm on. That's going to end up being 15. 30 divided by 2 is 15, so I'll end up having 15 times that quantity of x to the third, lowered 1 power, so that'd be to the 4th power. Then I'll raise my negative y another power, so that'd be to the 2nd power. Plus, let's get the next term. So I'm going to bring that 4 down in front here, multiply it by that coefficient of 15. 4 times 15 is 60, divided by the current term number I'm on, which is 3. 60 divided by 3 is 20. So this will be plus 20 times that x to the third lowered 1 degree. So that'd be x to the third raised to the third, times my negative y raised 1 more power. So that'd be negative y to the third. Let's get the next term. Alright, so I'm going to bring that 3 down in front, multiply it by that coefficient of 20. 3 times 20 is 60, divided by the term number I'm on, which is 4. 60 divided by 4 is 15. So this will be 15 times that x to the third lowered yet another degree. That'd be down to the 2nd power. I'll raise my negative y to the 4th power at the same time. Plus, let's get the next term. Well, 2 times 15 is 30, divided by the term number I'm on, which is the 5th term. 30 divided by 5 is 6. So this would be 6 times my x to the third, lowered yet another degree, which would just put it to the 1st degree, times my negative y raised another degree, which would be to the 5th. And we got one more term, which should actually be the final term. So bring that 1 that's on the x to the third is that power down in front here, multiply it by 6. 1 times 6 is 6, divided by the term number I'm on, which is 6. That just gives me 1. So that'd be 1 times that x to the third raised to the 0 power. That's also 1. So this would just be plus that negative y raised to the 6th power. So let's simplify this. So I would end up having here for the first term, I'll still have, let's go up here. X to the third raised to the 6th, that's going to end up being x to the 18th power. And then plus 6 times x to the third raised to the 5th, that would be x to the 15th power. Of course, times negative y. Plus I'll have 15 times my x to the third raised to the 4th. Well, that would be x to the 12th. Times my negative y squared. That would end up turning into positive y squared. Plus, we have 20 times x to the third, that would end up being x to the 9th, times my negative y raised to the third, well, that would just be negative of y to the third, plus, we have that 15 times x to the third raised to the second, that ended up being x to the 6th, times negative y raised to the 4th, well, that would just turn into y to the 4th power, plus we have 6 times x to the third times that negative y raised to the 5th, that would just turn into the negative of y to the 5th, plus negative y to the 6th, which would just become positive y to the 6th. So we simplify this one more time. You should get x to the 18th minus 6x to the 15th y plus 15x to the 12th y squared plus, I'm sorry, actually this will be minus 20x to the 9th, y to the 3rd, plus 15x to the 6th, y to the 4th, minus 6x to the 3rd, y to the 5th, plus y to the 6th. So there's all 7 terms of this binomial expansion. That was quite bad, wasn't it? So we have x to the 18th minus 6x to the 15th y plus 15x to the 12th y squared minus 20x to the 9th y to the 3rd plus 15x to the 6th y to the 4th minus 6x to the 3rd y to the 5th plus y to the 6th as the final answer. Alright, so these have just been some basic binomials. Let's do a couple that have fractions. We'll do 2 that have fractions. Because you can do them with more than just basic binomials. So let's see here. Let's say we have something as simple as 1 over x plus y raised to the 5th. So we're going to take 1 over x plus y, that entire quantity raised to the 5th. Well, like you would for anything, you'll take your first term, in this case that 1 over x, raise that to the 5th power. Now we'll get the next term, you'll bring that 5 down in front of your coefficient of outside the parentheses. Well, 5 times 1 is 5 divided by your first term, which is 1. 5 divided by 1 is 5. So this would be plus 5 times that 1 over x lowered 1 degree, so 1 over x raised to the 4th, times that y raised a degree, so that would just be times y to the 1st. Now, to get the next term, I'll take that, bring that 4 down, multiply it by 5. 4 times 5 is 20, divided by the term I'm on, which is 2. 20 divided by 2 is 10. So this will be plus 10 times that 1 over x lowered yet another degree. That would be to the 3rd power. And then you'll raise your y another degree, which would end up being y squared. Plus, we have now, let's get the next term. So bring that power of 3 down, multiply it by that coefficient of 10. That's 30 divided by the current term I'm on, which is the 3rd term. 30 divided by 3 is 10. Times that 1 over x lowered yet another degree, so that would end up being 1 over x raised to the 2nd. Then raise that y another power, so that'd be y to the 3rd. Let's get the next term. So bring that 2 down in front here, multiply it by the 10, that gives me 20, divided by the current term number I'm on, which is 4. 20 divided by 4 is 5. So that'd be 5 times that 1 over x lowered a degree, which would just be to the 1st power, times that y raised another degree, so that'd be y to the 4th. Then we should just have one more term. Bring that 1 power that's on the 1 over x down in front here, multiply by that coefficient of 5. You get 5 divided by the term number you're on, which is 5. 5 divided by 5 is 1. Times that 1 over x to the 0 power, also 1. So you're just left with y to the 5th. So we can simplify this pretty quickly. 1 over x raised to the 5th is simply 1 over x to the 5th. Plus, okay, so 5 times 1 over x to the 4th, that's times y. That's going to give me 5y over x to the 4th. Plus, alright, that 1 over x to the 3rd is simply 1 over x to the 3rd times that y squared times 10. That's going to give me 10y squared over x to the 3rd plus, let's do the next one, 1 over x raised to the second is 1 over x squared times y to the third times 10. So this would be 10y to the third over x to the second plus, okay, so we have 1 over x is just that times that y to the fourth times 5. You'll end up with 5y to the fourth over x plus your final term of y to the fifth. So all 6 terms of this binomial expanded here, you end up with 1 over x to the fifth plus 5y over x to the fourth plus 10y squared over x to the third plus 10y to the third over x squared plus 5y to the fourth over x plus y to the fifth. All right, we'll do one more fraction and then we're going to get into some radicals. Okay, so let's do this one. We'll have it lowered 1 degree. So let's do 2 over x minus y raised to the fourth power. We're only going to the fourth power, which means we should have 5 terms. Well, like you would always, take your first term, raise it to that highest power. So you'll take that 2 over x, raise it to the fourth power. Now, to get your next term, bring down that 4, multiply it by your coefficient outside the parentheses of 1. 4 times 1 is 4, divided by the term number you're on, which is 1. So 4 divided by 1 is 4. Now take that times that 2 over x lowered 1 degree, so 2 over x raised to the third power, plus to get you, but actually we got to take that negative y also, raise that 1 degree. That would just be times negative y. Now we can go for the next term. So bring that 3 down, multiply it by that 4. Well, that's 12 divided by the term number you're on, which is 2. 12 divided by 2 is 6. Then you'll take that times that 2 over x lowered 1 degree. So that'd be 2 over x raised to the second times that negative y raised 1 more degree. So that'd be times negative y to the second. Let's get the next 2 terms. Okay, so bring that 2 down in front and multiply it by that coefficient of 6. Well, 2 times 6 is 12, divided by the term number you're on, which is 3. That should give you 4. So 4 times that 2 over x lowered yet another degree. That would just be 2 over x to the first, times that negative y raised another degree. So that'd be negative y to the third. Then we should just have 1 more term. Bring down that power of 1 on the 2 over x, multiply it by 4, you get 4 divided by the term number of 4. That should just give you 1, times that 2 over x raised to the 0, that's also 1. So you should just end up with plus negative y to the fourth power. So now let's simplify this. So the first term should become 16 over x to the fourth plus 4 times, all right, 2 over x to the third, that's 8 over x to the third, still times negative y, plus we have 6 times that 2 over x squared. That would end up being 4 over x squared. Now that negative y to the second becomes positive y to the second. Alright, and then we just have 4 times 2 over x. That would just become 8 over x. Now that negative y raised to the third, that'd be times negative y to the third. Plus that negative y raised to the fourth, that becomes plus y to the fourth, which the final answer should end up being 16 over x to the fourth minus 32y over x to the third plus 24 y squared over x squared minus 8y to the third over x plus y to the fourth. So yes, that was quite long, but there's your 16 over x to the fourth minus 32y over x to the third plus 24y squared over x squared minus 8y to the third over x plus y to the fourth. Alright, so we can also expand radicals. We'll get into some radicals here. So let's say I take something like the square root of x plus 5 to the fourth. So now I have a radical in the binomial. Well, we're going to do this much the same way. Now, what I'm going to suggest first, any radicals you have, go ahead and convert that into a rational power. That's going to make your life a lot easier. So you can treat that as x to the 1/2 plus 5 raised to the fourth. Now we have something we can readily work with. So let's go ahead here, let's start expanding to the fourth power. So you'll take that x to the 1/2, raise that to the fourth, plus, to get the next term, I'll take 4 times my coefficient of 1, which is 4, divided by the term number I'm on, which is 1. So I would have 4 as my next coefficient, times that x to the 1/2, lowered 1 degree, so that'd be to the third power, times my 5 raised 1 degree, so that would just be 5 to the first, plus, now I'm going to take that power of 3, bring it down, multiply it by 4, get 12, divide by the term number of 2, I should have 6, times my x to the 1/2 lowered another degree, so that'd be x to the 1/2 squared, times my 5 raised another degree, that would also be 5 squared, plus I'm going to take that 2 down, bring it down in front of my 6 and multiply it. I'll get 12 divided by the term number I'm on, which is 3. That'll give me another 4 times that x to the 1/2 lowered another degree, which is simply 1. And then times my 5 raised another degree. Well, that ended up being 5 to the third. Plus, we should get one more term. Let's bring down that power of 1 on the x to the 1/2. 1 times 4 is 4. Divided by the term number of 4 is 1. X to the 1/2 to the 0 is also 1. So I should just be left with plus 5 to the fourth. Alright, let's simplify this. X to the 1/2 raised to the fourth, that just turns into x squared. Plus, okay, take your coefficients of 4 and multiply by 5, you'll end up getting 20 times x to the 3/2 plus, okay, we have 6 times, alright, x to the 1/2 squared, that's just going to end up being 6x times my 5 squared, that'd be times 25. Plus, okay, so 4x to the 1/2 is indeed 4x to the 1/2 times that 5 to the third, well, that's times 125, plus that 5 to the fourth, that's 625. Alright, so let's simplify one more time. You should end up getting x squared plus 20x to the 3/2 plus 150x plus 500 times x to the 1/2 plus 625. And sometimes you can leave it in powered form. If you were one of my students, I wouldn't care if you did that actually. That'd be just fine to me, but your professor, on the other hand, may not agree with that. What you want to do, just as one final check, let's convert these back to radical form. So x squared stays the way it is. But that 20x to the 3 halves, you could think of that the same as 20x times the square root of x plus 150x plus 500 times x to the 1/2. That's just plus 500 times the square root of x, then plus 625. So you may see your answer written one of these two ways, but that is exactly how the expansion would go. All right. Let's do one more with fractional powers, and then we're going to do a couple imaginary numbers. So yes, you can actually expand complex numbers with this too, but we'll get into that in a minute. Alright, this one's only going to be to the third power. So let's say we have x to the 2/3 power minus y to the 1/3 power raised to the third. So we have x to the 2/3 minus y to the 1/3, all that raised to the third power. Well, of course, your first thing you're going to do, take that x to the 2/3 and raise that to the third power. Now, to get your next term, bring that 3 down in front, multiply it by your coefficient of 1. 3 times 1 is 3, divided by term number 1, that's 3. So this would be 3 times that x to the 2/3 lowered 1 degree. So that would be x to the 2/3 raised to the second power times my negative y to the 1/3 raised a degree, which would just be to the first power, plus, let's get the next term, so bring that 2 down on the x to the 2/3, multiply it by 3, 2 times 3 is 6, divided by term number 2, that's also 3, but this would be 3 times that x to the 2/3 lowered yet another degree, which would just be x to the 2/3 raised to the first, times that negative y to the 1/3 raised another degree, so that would be to the second. And then for your final term here, we're going to end up then with that 1 as the power of x to the 2/3. Bring that down in front of your 3, multiply it by 3. You get 3 divided by term number 3, you just get 1. 1 times x to the 2/3 to the 0, it's also 1. So you should just end up with your final term of that negative y to the 1/3 raised 1 more degree to the third power. Alright, we got all the terms, let's simplify this. Well, x to the 2/3 raised to the third, that's just simply going to end up being x squared. Plus, alright, so we have 3 times x to the 2/3 squared, that would end up being x to the 4/3 times negative y to the 1/3. Alright, the next term here, 3 times x to the 2/3, indeed it's that, times that negative y to the 1/3 squared, that should give me positive y to the 2/3. Alright, then we have one more term, that negative y to the 1/3 raised to the third, that should end up giving me just negative y. Alright, so one more time when we simplify this, we should end up getting x squared minus 3x to the 4/3 y to the 1/3 plus 3x to the 2/3 y to the 2/3 minus y. So that would be your final answer. You get x squared minus 3x to the 4/3 y to the 1/3 plus 3x to the 2/3 y to the 2/3 minus y. Now let's do some imaginary numbers. So previously we did expand complex numbers with de Moivre's theorem. And that's a very useful theorem, especially when you have them raised to really high powers. But we can, of course, use the binomial theorem. Let's say I just do something like 1 plus I raised to the 4th power. So I'm going to take 1 plus I to the 4th power, but this time we're going to use the binomial theorem. So again, we'll just take that 1, raise it to the 4th power, plus to get our next term, bring that 4 down in front of our coefficient and multiply it. 4 times 1 is 4, divided by the term number we're on, well that's 4. I'm sorry, that's 1, excuse me. 4 divided by 1 is 4, so I'm going to end up getting 4 times 1 to the 3rd, because I have to lower the power on that 1 degree. Then I'll raise my I power 1 degree, so that would just be times I to the 1st, plus, now I'm going to take that 3, multiply it by that coefficient of 4, and get 12 divided by term number 2. That would give me 6 times my 1 lowered 1 degree, so 1 squared, times my I raised another degree. That would end up being I squared. Plus, let's get the next term. So 2 times 6 is 12 divided by term number 3, that's 4. So 4 times my 1 lowered yet another degree. Well, that would just be 1 to the 1st times my I raised another degree. That's just I to the 3rd. Plus, for the final term, I take that 1 power times my coefficient of 4. That gives me 4 divided by 4 is 1, times 1 to the 0 is also 1. This would just be plus I to the 4th. Alright, well, here's the thing though. It would almost look like we're done, but let's just simplify this. So 1 to the 4th is 1, plus, alright, what do we know here? 1 to any power is 1, so 1 times 4 is 4, so this is 1 plus 4i plus 6i squared plus 4i to the 3rd plus I to the 4th. Well, we're still not done yet, because if we remember, these i's, the imaginary number, the square root of -1, go in cycles of 4. Well, I is just that, it's I, it's the square root of -1, so this would be 1 plus 4i, plus, what is I squared? That's actually -1, so this would be plus 6 times -1, plus, okay, now what is 4i to the 3rd? Well, I to the 3rd is actually 4 times -i, that becomes -i, plus I to the 4th is just 1. So this is going to simplify into 1 plus 4i minus 6 minus 4i plus 1. Well, let's just collect like terms and simplify this. Notice the 4 i's are gone. We have no imaginary term. So 1 minus 6 is -5, plus 1 is -4. So this actually just simplified into a real number. You end up getting -4 as your answer. If you understand the cycles of I that repeat every 4, and you know how to simplify like terms, you should just get -4 as your answer. All right. Let's do this one. I got two more. I'll do this one and then we'll do one more. So 2 minus I raised to the fifth. So we have 2 minus I raised to the fifth. Well, of course, take your first term of 2, raise that to the fifth power. Now, we want to get the next term. So bring down that coefficient of 5, bring down that power of 5, multiplied by our coefficient of 1. 5 times 1 is 5, divided by term 1, that's 5. So you'll have 5 times that 2 term, lowered 1 degree, to the fourth power, times your negative I, raised a power, so that would end up being to the first power, plus now we need to take that power of 4, bring it down, multiply it by the coefficient of 5, you get 20, divided by term number 2, you get a coefficient of 10, times that 2 lowered yet another degree, so that'd be to the third power, times my negative I, raised to the second power, since we have to raise that a degree, plus, let's get the next term, so bring down that power of 3, multiply it by that coefficient of 10, you get 30, divide that by term 3, you end up getting 10, times that 2 lowered yet another power, so that'd be 2 squared, times that negative I, raised to the one more power, so that'd be to the third. Now bring down that power of 2, multiplied by that coefficient of 10, you get 20, divided by term number 4, you get 5, times my 2 lowered yet another degree, so that would just be 2 to the first, times that negative I, raised to the fourth, and then bring down that coefficient of 1 times 5, you get 5, divided by term 5, you just get 1, times 2 to the 0 is 1, so this would just be plus negative I raised to the fifth. So now we can start simplifying here. Well, 2 to the fifth is 32, that much we know. Alright, so that minus we can multiply by 5, so this will become minus 5 times 2 to the fourth is 16 times I. Alright, now we'll have 10 times, what is 2 to the third? That's times 8. Now negative I squared, that's just going to become positive I squared, plus, alright, 10 times 2 squared, that's going to be 10 times 4. Now the negative of I cubed, that would end up being, in fact, negative I to the third, plus, okay, 5 times 2 is 10, so that'd be plus 10, times now negative I to the fourth just turns in fact, to I to the fourth, plus negative I to the fifth, so that would end up being minus I to the fifth. Let's simplify further. So you'll end up with 32. Now 16 and 5, that's 80, so that'd be minus 80I. Alright, so then you have plus 80I squared minus 40I to the third plus 10I to the fourth minus I to the fifth. Now this is where you got to understand the properties of I, the imaginary number. So we can simplify those. So 32, of course, minus 80I. Now what is I squared? That's actually negative 1, so 80 times negative 1, that's just minus 80. Alright, now we have minus 40 times I to the third. Well, what is I to the third? That's just negative I, isn't it? So negative I times negative 40, well, that would actually become plus 40I. Now 10I to the fourth, well, I to the fourth is 1, so that would just be plus 10. Now I to the fifth, that repeats the cycle after 4, that would just be minus I. So we should get a final result when we collect like terms. For the complex number, the real component comes first, so 32 minus 80. In fact, let's just add these up here. So 32 minus 80 plus 10, that should end up giving you negative 38 for the real component. And then let's go ahead and do the imaginary component. So negative 80 plus 40 minus 1. So you should end up getting negative 38 minus 41I as the final answer for your complex number. So 2 minus I raised to the fifth will expand into negative 38 minus 41I. And actually, I think that'll do it for this lesson. So this is it for the sequence and series unit. The next lesson, we are going to start analytic geometry. In the very next lesson, we're going to start the conic sections. We'll talk about circles. But this is the unit that contains polar coordinates and graphs of polar equations and all kinds of really other cool things. So I hope everyone has a great day. Take care.